So this is a question on equilibria and case C calculations. There are a few sections to it. It's 8 marks in total, so I would recommend you pause on A, B, C and D, try to answer it and then review your answers by following through the rest of the video. So have a go at A. Now take a look at B. Try C. And finally on to part D. Okay, for part A then, state and explain the effect of using a catalyst on the yield of methanol in this equilibrium. So the important thing to remember here, as a very common question, is that there is no impact on yield. Catalyst does not change the yield at all. However, that's because the forward and reverse rates increase equally. So because that happens, there's still an advantage to using the catalyst because it will get you to your yield more quickly. Okay, moving on to part B, and we've got here writing out the equilibrium constant Kc for the reaction, and I've provided the equation there again. So the important thing to remember here is that you put products over reactants. You must also put it in square brackets because that tells us that it's concentration in moles per decimeter cubed. So reactants go on the bottom, but not quite finished yet because we need to use the balancing of the equation when we're considering the powers in our Kc expression. So I have H2 squared. Okay, moving on to part C. And we have here a calculation. We're told what the equilibrium mixture contains, but there's still a little bit of work to do. We're told that we've got 0.34 moles of carbon monoxide, 0.19 moles of hydrogen, and 0.061 moles of methanol. However, we're also told that the volume of the container is 250 centimetre cubed, and Kc isn't about the number of moles, it's concentration. So when I put my figures in, my moles are each going to be divided by the volume. And I've done that in quite a long-winded way here. You could do it over 0.25, but I just wanted to show precisely where that came from. The cm cubed needed to be converted to dm cubed. When you put all of those figures in, you end up with a value of 0.311. Moving on to part D. And on here, what you will notice is that we are looking at the reverse reaction of the one that we have just been considering and that we've just done the calculation for. So this isn't part of the answer, but you can see that the Kc is the products are now reactants, the reactants are now products, the one that was on the bottom is now on the top, the one that was on the top is now on the bottom. Now for that reason I don't need to go through the whole calculation again. I know that my answer is going to be 1 over the answer that I got in C because I've simply flipped the expression. So because I know that my answer was 0.311, my answer is 1 over 0.311, giving me a value of 3.22. Again, with the units, you could simply flip the units that you had previously, but I am going to go through the process here. If I substitute all of those units in, you can see that I can cancel out 1 mole dm to the minus 3 on the top and on the bottom. That leaves 2 or mole dm to the minus 3 squared. So I open that out and I get mole squared dm to the minus 6.